Today's video is on integration using residues. In today's video, we are going to evaluate the integral using residues. So by the method of residues, we have to evaluate integral 0 to pi d theta by a plus b cos theta is equal to pi by root over a square minus b square. Here, a is greater than b is greater than 0. Or otherwise, we have to show that integral 0 to 2 pi d theta by a plus b cos theta is equal to 2 pi by root over a square minus b square. So this is the integration around the unit circle. So in this video, we have to evaluate this one. So first of all, we have to consider this unit circle. So now, in order to consider the unit circle, we have to put z is equal to e power I theta. So what is e power I theta? So this is cos theta plus I sin theta. So if I consider modulus on both sides, that is modulus of cos theta plus I sin theta, then this will become, so mod z is equal to root over this value is cos square theta plus this is a sin square theta, which is equal to 1. Therefore, we got mod z is equal to 1, which is a unit circle. And the next thing here is z is equal to, so here what is our z? Z is equal to e power I theta. If I make a derivative on both sides, then dz is equal to e power I theta into d theta again. So I want d theta value. For substitution, I want d theta, and therefore d theta is equal to, this is dz by, see here, e power I theta is again e power I theta and I into d theta. So d theta value is equal to dz by I into e power I theta. So what is e power I theta? Which is equal to z. So d theta is equal to dz by zi. Clear? And next thing here is we need cos theta value. So we need cos theta. After finding d theta value, cos theta. So what is this cos theta value? So for finding the cos theta, so as you know that cos theta can be written as e power I theta plus e power minus I theta by 2. Clear? Then cos theta is equal to, this is z plus e power I theta is nothing but z value here. Z plus this value is z inverse by 2. So cos theta is equal to z plus 1 by z by 2. So cos theta is equal to, so if I take z as LCM, this will be z square plus 1. So cos theta is equal to, this value is z square plus 1 by, see here, z square plus 1 by z. Already there is 2 here. So this value is z square plus 1 by 2z. So all the three values are ready as it's a unit circle. The region is also found after putting z is equal to, what is the z value? E power I theta, and dz value is equal to dz by I theta, and next one cos theta value is equal to z square plus 1 by 2z. Clear? So now we have to find this integral. For finding this integral, we got all the values ready as, see, first value here is z is equal to, the first value here is z is equal to e power I theta. I am writing z is equal to e power I theta. And next one, d theta value here I am writing as dz by zi. Clear? And the next one, cos theta value is equal to, what is this cos theta value? Z square plus 1 by 2z. So this value is z square plus 1 by 2z. Now I need this integral. So which integral? That is integral 0 to 2 pi a plus b cos theta. Now I am going to substitute each and everything here. That is integral 0 to 2 pi. Consider integral 0 to 2 pi d theta by, this value is a plus b cos theta. That is integral 0 to 2 pi d theta value is nothing but dz by zi. Clear? And next one, this value is a by b times of, what is cos theta value? This value is z square plus 1 by, this value is 2z. And therefore this can be written as integral 0 to 2 pi dz by, so if I get it down, this will be zi times of, if I take 2z common, clearly this will be 2a into z, plus if I multiply this one, this will be z square b, plus if I multiply, this is b inside. So if I cancel the z and send 2 to the numerator, So 2 to the numerator, this will be 2 by I. So here there is I left. This is 0 to 2 pi. This value is dz by. If I write this as bz square plus 2a into z plus b. So this is nothing but integral 0 to 2 pi d theta by this value is a plus b into cos theta. Clear? After substituting d theta as dz by zi and cos theta is z square plus 1 by 2z, and after taking 2z as LCM and cancelling z and sending 2 to the numerator, this is 2 by I times of. So this is our function. So what is our function value here? The function is nothing but integral f of z into dz. So remaining part of integral and dz, everything is f of z. So f of z is equal to 2 by I times of this value, this bz square plus 2az plus 2az plus b is our f of z value. So first of all, before using residue theorem, we have to find the poles. So how we have to find the poles? So for finding the poles, we have to equate this denominator to 0. So what is this denominator? That is I times of, see this is I times of, this is bz square plus 2az plus b to 0. So if I send I to other side, so this will be bz square plus 2az plus b to 0. For finding the roots, we have a formula that is minus b plus or minus root over, this is b square minus 4ac by 2a. Here this value is a, this is b, and this value is c. So if I substitute here, in place of b we have minus 2a minus b plus or minus root over b square, that is 4a square minus 4 into a value is this b and c value is again this b by 2a, 2 into a. So this is minus 2a plus or minus root over, this is 4a square minus 4b square by the value here is 2a. See, this is minus 2a plus or minus. If I take 2 common from this root, this will be a square minus b square by 2a. So if I take 2 common and cancel in the numerator and denominator, this will be minus a plus or minus root over a square minus b square by. So in place of a, we have b here. This is 2b. This value is b. So this value is 2b. So if I take 2 common and cancel, then see, this will be, the roots will be minus a plus or minus root over a square minus b square by. So here also b. In place of a we have b. So this is the formula, that is 2b, 2b, 2b. So this will be b. So we got two roots. One is alpha value is equal to, see alpha, if I consider the two roots be alpha comma beta, then alpha is equal to minus a plus root over, this is a square minus b square by b, and beta value is equal to minus a minus root over a square minus b square by b. Clear? After getting alpha and beta, we have to find out whether it is the roots are. So these are the poles, not roots. So the poles are whether they are inside the region or outside the region. And let's check. See, first one, alpha value we got as alpha is equal to minus a plus root over, this is a square minus b square by b, and beta value is equal to minus a minus root over a square minus b square by b. So clear? And it is given that a value is a positive value. So here it is very clearly given that a value is greater than 0. So a value is greater than 0 and b value is also greater than 0. Let us suppose 1 is greater than 0. Clear? So if I keep 1 here and this is also some 1, then this will be minus 1 which will be minus 2. So beta value is clearly greater than 1. And this value will be less than 1. So alpha is equal to, if I take minus 1 here and this will be some 0 point something, so this will be less than 1. So this will be less than 1. So ours is a unit circle. So unit circle is nothing but, so this is a circle with 0. This value is, so this is the unit circle which is 1 here. This is minus 1, this is minus I, and this value is plus I. So beta value will be outside this one. So beta value will be outside the region B and alpha value is within the circle C. within the circle C. So the circle here is mod z is equal to 1, which unit radius and the center is 0. So this is the unit circle alpha and beta. So alpha is greater than 0, beta is greater than 0, and therefore the value here beta value is clearly greater than 1, therefore it is outside the unit circle. So there is no need of finding the residue for beta as it is an outside pole, and therefore we have to find the pole at point alpha is equal to 1. And what is our f of z here? So f of z value is, so our f of z value is this one, that is f of z is equal to clearly f of z is equal to 2 by I times of 1 by, so this is bz square. So this value is bz square plus 2az plus b. Now we can write this as, so we can write this as, if I take b common from this, f of z is equal to, see f of z is equal to, this is 2 by I into b. If I take b common, this will be z square plus 2a by b into z plus b by b. Clear? So this will be 2 by bi, and this can be written as z square minus of minus 2a by b into z plus 1. So if you consider this one, alpha value is this one here. Clear? Alpha is equal to, see here, alpha is minus a plus root over, this value is a square minus b square by b, and beta value is as clear as minus a minus root over a square minus b square by b. So if I add these two, alpha plus beta, alpha is equal to minus a by b plus root over, this is a square minus b square by b, and beta value is minus a by b minus root over a square minus b square by b. So now I can cancel these two, and this is minus 2a by b. So we got alpha plus beta value as this one. And next one, if I multiply alpha into beta, so what is alpha? This is minus a plus root over a square minus b square by b, into beta is minus a minus root over a square minus b square by b. So this is a plus b into a minus b. So alpha beta value is equal to, this is a square minus this value is, see here, this is b square. So alpha beta value is equal to a square by b, a square by b square. If I cancel this root and square, so this will be a square by b square minus of minus plus. So this value is b square by b square. So even if I cancel this one and this one also, so we got alpha by beta value is equal to 1. So let me show you how we got this. So this can be written as f of z value can be written as 2 by bi times of 1 by z square minus, so this is minus 2a by b is nothing but the sum of the roots, that is alpha plus beta into z plus 1 can be written as product of the roots alpha plus beta. How we got this? So here these are the few extra steps for your clarity. So this can be written as z square minus z alpha minus z beta plus alpha beta. Clear? And this is 2 by bi times of. So if I take z common, this will be z minus alpha. If I take beta common, then this will be z minus alpha again. So this is 2 by bi is equal to, if I take z minus alpha common, so here what remains? Z minus beta. Z minus beta. So this is our f of z value. So this is our f of z value. So we have to find the residue at interior pole. So what is our interior pole? Alpha is an interior pole. Alpha is interior pole inside the region, interior pole. So we have to find the residue value of f of z at point z is equal to alpha. So which is equal to limit z tends to alpha. This is z minus alpha times of f of z. So what is this f of z? F of z is ready as, so f of z value is ready, which is equal to, this value is equal to, this is limit z tends to alpha, z minus alpha into, what is our f of z? This is 2 by bi times of 1 by, this is z minus alpha into z minus beta. So z minus alpha after cancelling, we have to substitute z is equal to, in place of z as alpha. In place of z, we have to keep alpha. This will be alpha minus beta. So what is alpha and what is beta here? So this is residue value. So this value will be 2 by bi times of 1 by alpha minus beta. So what is our alpha and beta values? Alpha and beta values are this one. So this will be 2 by bi times of 1 by alpha is nothing but minus a by b plus root over, this is a square minus b square by b, minus of this one, minus of minus, plus a by b minus of minus, plus root over, this is a square minus b square by b. And now I can cancel these two, and what remains here? This is 2 by bi times of 1 by 2 times of root over a square minus b square by b. Now I can cancel this b and 2 also. So this will be 1 by I times of root over a square minus b square. So this is nothing but integral 0 to 2 pi. So this is nothing but integral 0 to 2 pi a plus b cos theta. So this is nothing but a plus b cos theta d theta by a plus b cos theta. So this is our pole value. At z is equal to alpha, we got the residue value. Residue value at z is equal to alpha. See here, at z is equal to the residue value of f of z at point z is equal to alpha is nothing but 1 by I times of root over a square minus b square. And therefore, we have to apply this residue theorem. So what is a residue theorem? Residue theorem is nothing but residue of f of z at z is equal to alpha is equal to I times of root over a square minus b square by residue theorem. By residue theorem, what does this residue theorem states? It states that integral, so this is integral f of z into dz is nothing but 2 pi I into sum of the residues. Sum of the residues at interior poles. At interior poles. So this is nothing but residue of f of z at alpha. Z is equal to alpha. Therefore, integral 0 to 2 pi, this value is d theta by a plus b cos theta value is nothing but 2 pi I times of the residue value here is 1 by I times of root over a square minus b square. So this is a residue value at interior point alpha. Alpha if I cancel, then this will be integral 0 to 2 pi d theta by this value is a plus b cos theta, which is equal to, this is 2 pi by root over a square minus b square. So this is 0 to 360 degrees. So we can write 2 times of 0 to 180 degrees. D theta by a plus b cos theta value as this value is 2 pi by root over a square minus b square. So if I cancel this one, this will be 0 to pi d theta by a plus b cos theta value is equal to 5 times of root over a square minus b square. So now we got the two values, that is integral 0 to 2 pi d theta by a plus b cos theta as this one, and if it is integral 0 to pi, the value is pi by root over a square minus b square. So this is how we have to solve, and let me explain you once again. See, first of all, it is asked that 0 to pi d theta by a plus b cos theta as pi by root over a square minus b square. So, and again we have to show that integral 0 to 2 pi d theta by a plus b cos theta is equal to 2 times of. That's what I have shown. For 0 to 2 pi, it is 2 pi by this one. See here, for 0 to 2 pi, this is 2 pi by root over. For 0 to pi, this is only pi by. So for 0 to pi, this is pi by root over a square minus b square. Both are solved, and therefore, as it is around the unit circle, z is equal to, we have to put z is equal to e power I theta. Z is equal to cos theta plus I sin theta, and modulus of z is equal to 1. So we have to make a derivative, and d theta is also ready for substituting here. And cos theta also, we have to make a calculation. Cos theta is equal to z plus 1 by z by 2. So which is equal to z square plus 1 by 2z. So as we got all the values ready here, as Z value is ready, d theta value is ready, and cos theta value is ready. So we have to use this integral. In place of d theta, we have to write dz by zi, and in place of cos theta, it is z square plus 1 by 2z. And after solving, so this will be f of z value. So keep it aside, and after that, we have to find the poles. For finding the poles, we have to equate the denominator to 0, and so for finding the poles, we have to find the roots for this. So for finding the roots, so this is the formula, and after substituting, this will be minus a plus or minus root over b square minus 4a 2a. So after substituting, these are the roots. So have considered alpha beta are the roots. Alpha is this one and beta is this one. So after getting the roots, so we have to check whether the roots are, whether the poles are inside or outside or within the circle. So as it is a unit circle, as a is greater than 0 and b is also greater than 0, so both are greater than 0, so this will be greater than 1. So this will be greater than 1, and this will be alpha will be less than 1. So alpha will be within modulus within the region, and beta will be outside the region. So we have to find the residue value for this. So residue value at alpha. So as this is f of z, I am modifying this one. So it took so many steps, but you have clarity for this. So this is f of z value is this one. I have taken b common from this. After taking b common, I have written like this. So 2a plus b, so this is nothing but alpha and beta. After adding some of the roots, as this one is minus 2a by b, so in place of 2a by b, I wrote alpha plus beta. As per is product of the roots is alpha beta is 1. So in place of 1, I have written alpha beta, and therefore after taking z common and beta common, this is z minus alpha into z minus beta. As it is a direct step in this textbook, I have given you clarity, and don't feel that it's a lengthy. So your clarity is most important to me. So after getting f of z, residue at point z is equal to alpha, that is limit z tends to alpha, z minus alpha into f of z. So after keeping f of z and cancelling and substituting z value as alpha, this is alpha minus beta. So alpha minus beta is this one. So this is the residue value at alpha, z is equal to alpha. We got this one. After getting the residue value, so we have to use residue theorem. Residue theorem is nothing but integral f of z dz is equal to 2 pi I into sum of the residues at the interior poles. So 2 pi I into the residue value. So this is the residue value. After cancelling this one, and this is 0 to 360, and we can write as 2 times of 0 to 180, and this is the final answer. This is how we have to solve. Thank you so much for watching, as this is most important question. Please practice, and if you doesn't understand, go through this video for one more time, and for each and every step I have given you a clarity, as though it is very lengthy, but your clarity is most important. After getting clarity, you can smoothly go with your steps, with your own steps, and I'll be uploading so many videos related to these series. Please go through those, practice well, and pass it on to your friends, and subscribe to this channel. And please once again watch the playlist, and so many videos are uploaded for your preparation. Please avail those. Thank you so much.